This video is for the lab Build a Compass, and the objective for this lab is magnetize and remagnetize a compass to assume different orientations in Earth's magnetic field. In the pre-lab video, I showed you how to set up the compass. It's got a base and it's got a top that can move freely on the base of the compass. And I explained to you, in order to magnetize the pins or the nails or the paper clips that you're using to build your compass, one very effective technique is to take your magnet, in this case I have the south pole of the magnet, and swipe it in one direction along the length of the metal paper clip, pin, nail, whatever the case is. Since I am using the south pole of the magnet, what I'm doing is I am orienting the spin of the domains and the iron of this paper clip to line up so that if this paper clip were to dangle freely in Earth's magnetic field, the paper clip would point north, like the direction that I'm swiping in. This end that I swipe off of is going to point north, and then obviously by default the other side of the paper clip is going to point south. It is equivalent in the lab to holding the south pole of the magnet to the end of the pin, paper clip, nail, whatever it is you're using. So I've magnetized my pins on my compass right here, and one thing that I wanted you to notice is that at rest, before I mess around with this, notice that my geographic north pointing pin is not pointing due north. In fact, that pin is just a little bit off to the west. And this observation is going to be very important when we talk about angle of declination. Okay, since this particular pin is pointing towards the geographic north, I wonder what would happen if I hold a magnetic south pole towards the head of that pin. And they attract. So the flat head of the pin that is pointing geographic north is attracted to the south pole of my magnet. I wonder what will happen if I flip my magnet over so that the north pole points towards the head of the pin, and it repels. So I had put a little bit of color on the foil there just so I could tell which pin I had magnetized to point which direction. The pin that's got the colored foil, the pin head, is pointing geographic north, and it attracts to the south pole of the magnet. It is repelled by the north pole. But as you can see, my compass needle is now attracting to the north pole because the not colored one is the south pole pin. Okay, so I let it go. Kind of knocked it off of its base there, but it's going to reorient itself in Earth's magnetic field lines. Now, what's going to happen if I take my south pole of the magnet and I swipe along one direction here, but instead of flipping the magnet to the other side, I just swipe again, with the south pole of my magnet. That means I have just swiped both of the pins for the top of my compass with the same pole of the magnet, both sides south. All right, so let's see what happens now. And it's kind of bumping up against the edge of the paper, so I'm going to try to balance that better so we get an accurate result. Okay, more or less doing what I thought it would do, which is it's going more east-west, not as dramatic as I was hoping for, but it's going more east-west than it had been previously. Let me just give it a try this time with the North Pole. So I'm going to go North Pole, North Pole. So I'm remagnetizing each of my pins with the North Pole of a magnet. Now let's see what happens, because this is the fun of science. What will happen? And again, about what I thought would happen. It's more east-west than it had been previously. Again, not as dramatic as I had hoped, but it's still going east-west. So there you have it. How does remagnetizing the pins affect the colored pins' resting position? Well, if you magnetize both pins by the same pole, the head of the compass is going to point more or less east-west. And if you magnetize the colored pin towards the south pole of the magnet, that colored pin points geographic north, which leads us to a really important observation. Just like determining the charge on an electron, which side of a magnet is by definition the north pole of the magnet is something that's just created by humans. By definition, if the north pole of a magnet on a string points geographic north, that means that the magnetic pole has to be a magnetic south pole up by where Santa Claus lives. I know a lot of people are saying, what? Because if you look at any map, it's going to say magnetic north next to where the geographic north is. But technically, if you think about the definition of what side of a magnet is the north pole of a magnet, if the north points towards the geographic north, it has to be attracted to an opposite magnet. So it's, by definition, got to be a magnetic south pole up there by where Santa Claus lives. Think about that one. The end.